Hello. For over 20 years, SAS Environmental Services has had the aim of reducing the environmental impact of oil waste treatment. We've done this through our unique microemulsion technology. Increasingly over the past years, it's become clear that if we really want to look at reducing the environmental impact of what we do, we have to include in that assessment the carbon footprint of the processes involved. In this video, what I want to do is compare a more traditional oil sludge disposal route with treatment through our MIST process system. We've had to make a number of assumptions in order to make this comparison, and those assumptions can be found in an accompanying download, which contains all of the numbers and assumptions that we had to make in order to create a comparison. If you are interested, I urge you to download it, comment on it, and provide us with your feedback. In this particular comparison, what we're looking at is a refinery or waste storage site that has about 50,000 tons of oil waste which needs to be disposed of. Traditionally, this would be taken from the storage tanks, or it might be taken from waste pits, and this waste is taken in trucks. In this case, we've assumed 15 ton per truck, and driven 600 kilometers to a disposal site or perhaps an incinerator. Now, those are all pretty typical numbers. 50,000 tons is a pretty typical project size for us. 600 kilometers to a disposal site is pretty common. It's been more, it's sometimes less. It's a pretty good assumption. And what you get when you look at that is that the transport is by far the largest element in that carbon footprint of this waste disposal. And you're looking at about 4,700 tons of CO2 equivalent greenhouse gas emissions associated in getting rid of this waste. Now, when we compare this to the SAS Environmental Services MIST process, which is a low power, low energy engineering process that uses our unique microemulsion chemistry to separate the oil sludge at the site of storage into oil, water, and solids, we get a very different story. The oil and water are recovered at the site of waste storage, which means the oil can go back into the refinery or storage tank. The water is simply discharged, sometimes with a little bit of polishing after treatment. And it's only the solids that are recovered from this process that are the actual waste that has to be disposed of. Now, the solids are typically about 10% of this refinery sludge. And so these solids need to be transported and then disposed of. And so what we're getting in this particular scenario is a carbon footprint of just over 1,400 tons of CO2 equivalent greenhouse gas emissions. That's a reduction of 70% compared to just disposing of the entire waste. So there is a carbon footprint associated with manufacturing our engineering and transporting it to site. There is a carbon footprint associated with the production of our chemistry and transporting our chemistry to site. And obviously there is a small energy cost in running our process, although it's small because it's such a low energy process. But by treating the waste at the site of storage or production, and by removing so much of the oil and water, and having such a phenomenal reduction in transport, we can really lower that carbon footprint of waste treatment. So this is the first video. We have more scenarios to follow. Please have a close look, download the fact sheet, and I look forward to hearing your comments. Thank you. Bye.